of the beginning of time, which it really follows on very nicely from Jocelyn's talk, because he touched on a number of the aspects of this talk this morning in the first session. And it's been written, this title I have got to acknowledge that I have taken from an article written by a certain Gabriel Veneziano, which sounds enormously appropriate for a talk in Venice, doesn't it? Appears to be a long-standing a theoretical physicist who has been in the game for 30 or 40 years. I guess he might even be on the verge of retiring if he hasn't actually retired. And he wrote this very, very authoritative article surveying the whole situation relating to the origin of the universe and what current thinking is on the subject. Now, he's not only a good scientist, I guess, but he's also a pretty articulate man. And he's written such an excellent introduction to this article that I'm going to begin my talk, very unusually for me, by actually reading this introduction to you, rather like reading, I suppose, the Bible before a sermon. Was the Big Bang really the beginning of time? Or did the universe exist before then? Such a question seemed almost blasphemous only a decade ago. Most cosmologists insist that it simply made no sense, that the contemplated time before the Big Bang was like asking for directions to a place north of the North Pole. But developments in theoretical physics, especially the rise of string theory, have changed their perspective. The pre-Bang universe has become the latest frontier of cosmology. The new willingness to consider what might have happened before the Bang is the latest swing of an intellectual pendulum that has rocked back and forth for millennia. In one form or another, the issue of the ultimate beginning has engaged philosophers and theologians in nearly every culture. It is entwined with a grand set of concerns, one famously encapsulated in an 1897 painting by Paul Gauguin. Where do we come from? What are we? Where are we going? The piece depicts the cycle of birth, life and death, origin, identity and destiny for each individual. And these personal concerns connect directly to cosmic ones. We can trace our lineage back through the generations, back through our animal ancestors to early forms of life and proto-life, to the elements synthesized into the primordial universe, to the amorphous energy deposited in space before that. Does our family tree extend forever backwards? Or do its roots terminate? Is the cosmos as impermanent as we are? The ancient Greeks debated the origin of time fiercely. Aristotle, taking the no beginning side, invoked the principle that out of nothing, nothing comes. If the universe could never have gone from nothingness to somethingness, it must always have existed. For this and other reasons, time must stretch eternally into the past and the future. Christian theologians tended to take the opposite point of view. Augustine contended that God exists outside of space and time, able to bring these constructs into existence as surely as he could forge other aspects of our world. When asked what was God doing before he created the world, Augustine answered, time itself being part of God's creation, there was simply no before. So you see that the philosophy and the points of view that could be adopted by people in looking at the whole subject of time and the origin of time are really quite varied. And of course we start off from where we are. It's the only place to start in looking at this subject. Where we are, we have to accept that just in so many other areas of our lives, we are preset. Our attitudes and ideas have been preset in our childhood, beyond a point where we can totally eradicate them or get to a point where we're totally dispassionate and uninvolved with our own thoughts and memories. And this is really a great tragedy of human existence, that childhood preconditioning is so difficult to eradicate, because it makes it very difficult for us to look dispassionately at the whole scene and select what appears to be the most adequate explanation in any particular branch of our viewing of nature. And so in this particular aspect of time, we looked at clockwork time, as I call it. Clockwork time, which is very, very peculiar to this planet, so peculiar that it only really is generated by the spinning of the Earth on its axis, and to a lesser degree in our appreciation of the seasons by the Earth's orbit of the Sun. And that is where our perception of time comes from on a daily basis and on an annular basis, this clockwork time. And we link ourselves into this clockwork time by building mechanisms which tell us exactly where we are, from the early sundial, which could only work when the sun was out and no good on a cloudy day, to the very latest watches and clocks that we have, which have got little crystals in them that have a particular fundamental resonant frequency, which we can then use to establish the time and adjust it, gear it in such a way that it tells us what our solar clockwork time is. But I want to step back a bit from this detail, looking at our own personal concepts of time and experience of time as we live this human life, to looking at the universe from a slightly more fundamental point of view, because it will enable me to draw back upon these ideas later on in the talk. And that is to say that when the scientist comes to look at the nature that surrounds us, the reason why science in many ways has advanced so rapidly in the last 400 years, and particularly in the last 200 years, is because of the scientific method. The method, first of all, is to observe very accurately and carefully and conscientiously the workings of nature, and then to look for a hypothesis which would fit that. And it's only when a hypothesis has been established which fits the observed facts of nature that man begins to get some idea how he might control nature to his own advantage. And that applies in every branch of scientific investigation. And of course it leans particularly upon observing nature in three aspects. And the three aspects are, in evaluating and measuring the functioning of nature, are the three quantities of mass, length and time. Mass, the mass of the particles that constitute the atoms of our subatomic particles that constitute the atoms of our periodic table of elements, from which all the various molecules are constructed that we use in our human bodies, in the cells of our human bodies, and of course the length, which is cubed in our case. You'll see why I say cubed in our case, a three-dimensional space and time. Now, in many ways, as Jocelyn mentioned this morning in his lecture, the concepts of space and time are that we have physically are very similar in terms of the way in which we appreciate them. But when we come to look at the whole thing esoterically, the problems in transferring our way of thinking of clockwork time, as I call it, to fundamental concept of time is just as difficult as our ability to transfer our concept of three-dimensional space to multi-dimensional space, perhaps 6 or 7 or 10 or 12, or I think in some latest aspects of string theory they want to even postulate 21 dimensions of space. And even further than that, an even more difficult concept than that, and that's difficult enough, but we'll come back to that later in the talk, it is Blavatsky's own statement that there's such a thing as dimensionless space, 0 dimensions in space. Now you'll see again how this deeply impinges upon the subject of time later on, but at the moment I want to say to you that of all the teachings that I've come across in Theosophy, to grasp the full significance of what Blavatsky says in relation to dimensionless space is probably, for me, the most difficult. Incredibly difficult. And it is the gateway into an understanding of esotericism. It is, I think, one of the biggest and most important gateways into an understanding of what esotericism is all about. This idea of 0 space, abstract space, if you like, or occult space, whatever adjective you put behind it, or adjectival noun you put behind it. It is this concept that there's a space beyond and behind and within, possibly, physical space. Well, not possibly, it is. It's not definable outside or inside physical space because it's a different reality. And it's this ability to transfer our thinking and use our imagination, if at all possible, beyond our ordinary way of thinking about life and existence into this other realm that is so crucial to our understanding of esotericism. Now all this comes into play in an enormous number of ways in the next part of this talk. First of all, I want to show you you can miss the microphone if I don't carry it with me, I suppose. I want to show you the problem in graphical terms, really. Because the basic problem is this, that whatever parameters you look at in nature, you inevitably, as you observe nature, you have observations over a range of different conditions in nature, which we say the range is the parameter x. And if you're lucky, you can get them on a straight line. You can get at what we call a linearity. Now that straight line can be obtained even when the data has huge curves and shapes in it by manipulating x and y mathematically, by taking logarithms, by using trigonometry, by doing all sorts of tricks with the data so that you can get it onto a straight line. Because if you can't get it onto a straight line, then it's anybody's guess what sort of curve you draw through the points, because the points have a deviation about them which is much more difficult to manage on a curve than it is on a straight line. But much more important, so let's just draw a straight line through them, assuming that we've manipulated x and y in such a way that we can have a straight line. But there's a much more important thing here, and that is that this data has been gathered over a range of x, from x1, say, to x2. Now what happens if you want to know the way nature performs, y, outside this range of observation, x1 to x2? Supposing you want to know what is the value of y out here at x3. Well, the problem is that you're involved in something which the scientists call extrapolation. Most of you probably heard the word anyway. And how can you extrapolate another to extend a straight line? So you get another value for y. Oops, I've drawn the line too high. You get a value of y, y3. Now, supposing you're wrong, supposing that extrapolation is not true, supposing in fact it isn't a straight line from there to there, even though it's a straight line over the whole of this range x1 to x2, supposing it isn't a straight line, or supposing, and this becomes much more relevant to the subject this morning, supposing if you bring the line back this way, because you're interested in what happens here, say at x0, the origin of the universe, can you extrapolate back? Can you come back right to this 0 point here, or can't you? Big question mark. You say, well, you know, I've done so much work here, and I've managed to manipulate these quantities mathematically to get them all onto a straight line. I must be justified in extrapolating. And the history of science is that these extrapolations have led us into all sorts of trouble. Now, there's a particular example that after Newton had established his scientific theories of gravitation and so on for several centuries, suddenly there was a problem when it came to astrophysics. Over the huge distances of astronomical space, it was found that Newton's laws, which had been so well proved and well established down through the centuries, suddenly were failing. And you get this incredibly difficult thought, like the one I've just been talking about, relating to the nature of the abstract space. You get this incredible thought, which had to be shown by Einstein. It was Einstein who solved this problem with his theory of relativity. The distance between 2 points, I use the same piece of paper, the distance between 2 points is not, the shortest distance is not a straight line between the 2 points, but a curve. Now, that takes a lot of problems, doesn't it, for the human mind to grasp that space itself can be curved. And if you're following the curve, the shortest distance between those 2 points is round the curve, not drawing a straight line between them. Now, even if you're not a scientist, can you not feel the ground moving under your feet? Can you not feel that there's a concept of reality here which is very difficult to come to terms with? You've always known, since you were a toddler, that the shortest distance between two towns and two cities, or on a line on a piece of paper, was always a straight line. And suddenly you're being asked to something entirely different. You see? So somehow you've got to break the mould. As Jocelyn was saying this morning, you've got to break the mould of the way you think and start thinking to a different paradigm. Very difficult indeed. Now, why am I saying all this? Because scientists, in looking at the whole concept of the Big Bang, obviously want to use the observations of nature that have been established so far and project them back to the beginning of time. The problem is that as you project back here, you get to a point where the density of the material just doesn't, the mathematical equations just don't work right down here close to zero. And so everyone has said to themselves, well, there isn't a good explanation as to how you could possibly go back behind this zero. And the latest, the great message of our friend here who wrote this article is that modern string theory has enabled you to see how it's possible for the convergence of the galaxies as the universe implodes to reach a point where it isn't necessary for them to reach what's called a singularity. A singularity is when a notional position where the density of the universe is approaching infinity, and the volume of the universe is approaching zero. And this is the whole problem. That as the volume, the three-dimensional volume of the universe approaches zero at the Big Bang position, the density of the universe obviously reaches infinity. And that is the whole problem. Now, without going into all the complexities of the article, which you need to read several times to get a good grasp of it, unless it's your particular branch of science that you're into, in which case you can probably soak it up fairly rapidly. Without going into all the complexity, his idea is that the string theory permits another view of the way in which the universe originated, in inverted commas. And that is, let me just see if I've got my diagram so I can copy it. That is, we go back to our two axes again. And if we put the reciprocal of density over here, so as density approaches infinity, that equals approaches zero. So that means as the density, as I just said on the previous page, approaches infinity, that quantity approaches zero, doesn't it? Mm-hmm. So any quantity divided by infinity is zero. So this we're approaching zero. So the Big Bang is, so we're coming down here towards zero on the y-axis, coming down here. Now, as time advances, time in that direction, you can imagine that as the universe implodes, it comes down towards this zero line here for the y-axis. But instead of coming right down and touching the axis, it turns up again and starts to explode, and the galaxies start to go apart again. Now, if that happens, you're entitled to say that what is happening here is cyclic. It goes to a point of expansion at whatever this value is, 10,000 million years, 55 billion years, whatever the age of the universe is when it stops expanding and starts imploding. And then it starts coming back down again, and you develop a cyclic process. So you can see how the whole way in which scientists are now thinking of this subject gives you an entirely different way of understanding the nature of reality as far as the universe and time is concerned. Now, of course, it's all highly theoretical. Of course, no one can actually measure it. What science really does in these circumstances is to look at the one that looks most reasonable, has the highest probability of being accepted by the scientific community as common sense. And so the gradual advance of thinking in this subject is another example, in my view, of the convergence of science and esoteric science. As you know, all down through the last 150 years, there has been this gradual convergence of science and esoteric science. And this is another example of that case, because in the Secret Doctrine, Madame Blavatsky writes, "Time was not for it lay asleep in the infinite bosom of duration. Time was not, for it lay asleep in the infinite bosom of duration. Fantastic words which are so apt in this particular study this morning. And she is clearly drawing the same sort of distinction between time and duration as the sort of distinction I was drawing on earlier in the discussion in this talk between space and esoteric space, abstract space, occult space, space which has 0 dimensions. And here we need to look a little bit at the concept of time and duration. Duration is something which can apply outside of the physical universe, because basically duration is a measure of the frequency of events and is entirely different from clockwork time. Clockwork time that I talked about at the start of the talk. This is duration. So what do I mean by duration? Well, imagine, some of you have heard this example before, but some of you haven't, so I have to give it here because for me it's so powerful. You're standing at the bus stop on a cold, windy, wet day, and you would have liked to have had several more layers of clothes on because the wind is getting right through them all. And you're feeling really miserable. And on top of that, the bus is late. And on top of that, the people around you are all moaning. And every minute that goes by seems like an hour. You've all been in this situation. You know what it's like. You know, if you've got earache, every minute seems like an hour. And you know, that is our experience of time. But you get home eventually after the bus has come and you put on your party clothes and you go off to a party. And you arrive at 8 o'clock in the evening, and before you know where you are, it's midnight. You just can't believe it's midnight already. That's why parties go along to 4 o'clock in the morning, because people are enjoying themselves so much, you know. And even then it doesn't seem like the time you spent at the bus stop. You see the difference between time and duration. Duration is a measure of the frequency of events. You're standing at the bus stop, nothing is happening. That wretched bus is nowhere near in sight. But the moment you're enjoying yourself and all sorts of fascinating people are coming up and talking to you, and you've got lots of lovely food and drink, then time runs away. Because we're looking here at duration. And duration, you know the Hermetic axiom, as above, so below. Just think about what that means when you give up your physical body and move into another realm. It'd be exactly the same there as in your physical body. You were standing at the bus stop. Exactly the same. Your experience will be of duration. That is why this verse which Harold quoted from 1 Peter 3:16, I think it is, whatever the last verse number is so apt in this particular talk, because it says, with the Lord, 1,000 years are as a day, and a day is 1,000 years. You see, and it's all to do with duration. The significance of Earth time, when you're outside of time, is no significance at all. It's the way in which events take place in the other world, when you're beyond this physical world, which determine your experience of reality. And this is moving on to the preacher's spot for a moment, if you've spent your life not producing or inculcating any qualities in your own character which enabled you to appreciate the sort of parameters that are effective and interesting to you in the next life, of course it's going to be an absolute hell. It's going to be so boring that you can't imagine how you're going to survive it. But if you have become the sort of being that would enjoy the experiences of that other world, then of course it will be a magnificent thing. It will be an ecstasy. You know, the two things are, the whole thing fits together really remarkably well. Excuse me. There isn't any doubt that although I'm saying all these things to you this morning, the failure of the rational mind to measure or comprehend the incomprehensible and unfathomable is notorious. You know, I dare to say these things in this company without being ridiculed. But how many people could you say these things to out in the street? Because the rational mind isn't even prepared to contemplate the reality of the sort of things I'm talking about this morning. Yancey Hoskins, who was one of the founder members of this school, had a great favourite for this little book called Out of the Silence. You almost feel that it's a parody on the Voice of the Silence, don't you? But it's not. It's actually a sort of imaginative expansion by this man James Rhodes of 1 Corinthians 3:16. Know ye not that ye are the temple of God, and the Spirit of God dwelleth within you. And it was one of Yancey Hoskins' favourite passages. I remember I was in a meeting like this on one occasion, and she pointed at me in the middle of the meeting, and she said, "Colin, tell us what 1 Corinthians 3:16 is." So I actually had to stand up and recite these words off the cuff. This particular aspect of the verse of St. Paul, listen to it. Listen to what Rhodes makes of it. Is this thing true, the preacher saith, or but a dreamer's dream? Thrills in thy very midst the breath that bade the starfire's stream, framed all the universe divine, and slowly, cell by cell, built up thy body for a shrine wherein himself might dwell. And this is where you grasp little glimpses of theosophy within the Christian theology, because here we're saying that there isn't any way in which God can be out there looking in on the universe. There isn't any way, because there isn't an out there. There's a different realm of existence which underpins and supports the physical universe, and which exists regardless of whether the physical universe is there or not, whether it's going through the Big Bang and coming out again, or whether it's coming near to being a Big Bang and actually avoiding being a Big Bang and going through the cyclic motion. And so this idea that in the beginning was the Word already was, because it was not just a beginning, it just looked like one. It was really part of a cycle. And you can see how easy it is to be deceived in science, in looking at nature, by looking at just a part of nature instead of the whole width of nature, which is incredibly difficult to do and often impossible to do. You can get hold of completely the wrong end of the stick, or the wrong story altogether. At the end of the proem of the Secret Doctrine, before you ever get to chapter 1, Blavatsky lays down 3 fundamental propositions, which are the 3 bedrocks of all theosophical teaching. And the second of those goes like this: the eternity of the universe in toto as a boundless plain, periodically the playground of numberless universes, incessantly manifesting and disappearing. The appearance and the disappearance of worlds is like a regular tidal ebb of flux and reflux. you couldn't get a better description, in my view, of cyclicity than that. It is the whole concept that underlies all aspects of nature. There is a fundamental cyclicity of which the origin of the universe is a part, and that you can mistake the cyclicity of the universe coming in and out of existence, or even in and out of a singularity, using it in that special way in which I described it earlier in my talk. You can mistake it for a once-off event. There is no such thing as a Big Bang. There never was and there never will be, because the universe exists in a cyclic way. And not only the universe, but the whole concept of manvantaras and pralayas in Theosophy is built upon this concept of cyclicity. So the myth of the beginning of time really is a myth, in the bad old sense of the word myth, in the sense that it is a nonsense. Unfortunately, a lot of people still use the word myth as a way of talking about nonsense. And in a way, that is the way in which he's using the word myth in the title of this article, and the way in which I'm using it in the title of this talk. That we're not talking about a mythical experience, we're talking about a nonsense. Coming back to the string theory, coming back to the string theorists, they expect that when one plays the history of the universe backwards in time, the curvature of space starts to increase. This curvature of space that I was talking about earlier is in fact a variable, varies under certain conditions, or to do with the speed of expansion of the universe or the speed of implosion of the universe. The curvature of space changes. But instead of going all the way to infinity of density, it hits a maximum and shrinks once more. Before string theory, physicists were hard-pressed to imagine any mechanism that could be postulated which could eliminate the need for this singularity, where the mass of the universe goes down to zero volume and to infinite density. So it was just, in his own words, in his article, it was just the transference of implosion to explosion. And he concludes his article by saying, so when did time begin? Science does not have a conclusive answer yet, but at least two potentially testable theories plausibly hold that the universe, and therefore time, existed well before the Big Bang. If either scenario is right, the cosmos has always been in existence, and even if it recollapses one day, it will never end. I've had to miss out an awful lot of the fine detail because I really don't think it's possible to get into a one-off talk like this. But I do want to just say that there, apart from the string theory, there was another way of describing how there were two scenarios suggested. The other scenario was like this, and it's not all, and it is quite credible, but very difficult to visualize because you can't actually see yourself in looking at the real significance of going into more than 3 dimensions. Just as I said so many times already this morning, just as it's so difficult to visualize going outside of time, so it's very difficult to imagine going outside of 3-dimensional space. So what he postulates, or what the scientific community postulates, is that there is another realm of multi-dimensional space where 3-dimensional space can be seen as what he calls as sort of plates, really. That 3-dimensional space is drawn in as these plates in a multi-dimensional space in which 3-dimensional space can exist as a coherent entity. and that the Big Bang, so-called, is not in fact anything like this infinite density minimum zero volume end point, but it's simply two of these three-dimensional universes actually clashing with each other.
Nice.
And that they might even clash with each other in a cyclic way. You know, they clash and then they stay apart for a while and then they gradually come near together, whomp, they clash again like a pair of cymbals. And so these were the two theories that he examines in his article. But I think I've probably said enough to satisfy you for the moment. You've had 3/4 of an hour of it. Maybe you'd like to spend a little bit of time asking questions, but there's absolutely no guarantee you'll get the answers. There you are. Okay. Anyone? Yeah, yes, John.
The essence of all this seems to be succession. Doesn't that constitute the essence of time? That one thing happens before another one. Now, can you get out of that idea of succession and have time running backwards in this?
Yes, the whole business of negative time is a very difficult concept. They do, in fact, he does, in fact, discuss the use of the negative sign as the change from implosion to explosion. And he goes into a number of other fascinating details that immediately after the implosion, to this point where the original laws of science break down, immediately after that the expansion is so vast, is so incredibly fast, that it's faster than the speed of light. And so that the galaxies go out at such a speed that they're not able to send light back fast enough so that you can view it. And he says for the first time in the whole history of the universe, the galaxies have slowed down in their expansion to a point where the light is able to get back. So if we were perhaps Professor Lovell today, who built the Jodrell Bank telescope, as we were talking about yesterday, you might well say, well, now I am reasonably satisfied that the expansion of the universe has got a limit to it, because it's now possible that galaxies are slowed down so much that the light that they were emitting gets back to us and we can see it. And he says that in the article. This is the first time now in present history of the universe that we can actually see how far the galaxies have got. But at the early stage they were expanding so fast that the light couldn't get back fast enough to tell us where they were. So there are all sorts of fascinating details like that. But that in terms of actually turning back the clock in the sort of way in which it is thought about, you know, people suddenly finding themselves in the Victorian era or something like that in Earth time, I think it's a different thing altogether. You know, there are all sorts of factors coming into play. How much are the people who lived in the past able to, under certain unique circumstances, re-enter time? And if they re-enter time, are they able to re-enter time over a range of their choice? It may not be that time itself is reversed, but they have been able to come back into time at another point. And of course this is why we get all these feelings from time to time, some of us, that we've lived before. Because it's not that we're going back in time in actual consciousness, but we're going back in memory to a time, because, you know, as you well know, you know, one of the fundamental teachings of Theosophy is that the memory of everything that has ever happened in the history of the universe is embedded in the astral light, and therefore, and the Akashic records, and therefore it's merely a question of accessing, pulling the right file down out of the library and opening it up to re-enter that period of history in mind, but not in substance. So there are all sorts of fascinating things that underlie the question you've asked, but I'm just touching on them there, really. Yes, Howard?
Yes, and one of the interesting things about all this kind of thing is that in the recession and expansion of universes that we can see, is that the scientists make one huge assumption for which they have no proof at all, and that is that the speed of light is the same in every part of the universe. This is just a small example, and there's no way that can be proved by any scientific process, and it may not be true. If it is not true that in different parts of the universe the speed of light changes, for example, the whole concept of the expansion and recession of galaxies, for example, just falls to the ground.
Well,
it's just one example.
Well, it becomes less probable. Becomes less probable. But you see, you've touched really on the crucial point between ordinary, straightforward thinking and esoteric thinking in making that remark, because even if the speed of light is variable, and even, well, whichever way you answer the question, whether the speed of light is variable or not, you have this incredible phenomenon which Eddie has referred to in some of his talks recently, and which has been quite a debating point in recent times, that the communication can happen instantaneously.
Mm-hmm.
If you can communicate between two people or two objects or two atoms instantly without the passage of any time at all, which is what is being said, then you're almost saying, well, I've got a telephone here which enables me to dial a number and step outside of time, go along in another realm, and step back in again and be at the same moment in time that I was when I went out. Now, this is the absolute fascination of the convergence of science and esoteric science. Because this is something which the scientists are currently talking about, the ordinary scientists, not the esoteric scientists, that there's this speed of communication between atoms and possibly between people, which is not operating in finite time at all. And therefore there is another way of describing the realms of existence that lie beyond this physical world and this physical universe. And there's a demonstration of it, that even while we're still living in Earth time, we can actually step outside of time and come back again with no lapse of time at all. And so whatever happens to the physical universe, there's this question about the speed of light is not the same thing as the speed of communication, which is a fascinating thing altogether. Yes.
Well, I wonder if duration at this point, which you were referring before, as the perception of the event, means the absence of time, in terms of,
Well, yes. I mean, that was really part of the point I was trying to make, Anita. You see, that you actually, when you experience duration, in my standing at the bus stop going to the parties, as an example, you're not really interested in ordinary physical time at all.
Right.
What's happening on your watch is of little consequence to you.
Exactly.
You're still shivering at the bus stop and feeling that you want this to end as soon as possible.
So speed doesn't make sense
So
anymore.
speed of experience of events in Earth time terms doesn't make sense. It's not important.
Right.
What's important is duration, and this is why, I mean, you have to give it to the seers of another world another generation, another millennium almost. It is another millennium, just about. The psalmist says in Psalm 90 verse 4, 1,000 years are but as yesterday when it is past, or as a watch in the night. You know, I mean, it is so perceptive, a statement like that. It's so incredibly perceptive, because it's saying exactly what I'm trying to say about time and duration.
Yeah. Another question is, I don't understand really what you mean when you say density equals infinite.
Colin, can I just intercede here? I wonder if you would repeat the question, please, because we can't hear it here.
She says she doesn't understand what I mean by an increase in density. Density is the amount of mass you can get into a given volume. If you have a litre jug, you can get a litre of orange juice into that jug. You can also get a litre of air into it. But if you can seal off the top of the jug and you can compress 2 litres or 3 litres or 4 litres of air into that 1 litre jug, because you're increasing the density of the air in the jug. You can't increase the liquid in the jug because liquid is virtually incompressible. But gas isn't. So you can take perhaps 10 litres of air and compress it down into 1 litre of jug. You can take perhaps 1,000 billion galaxies of stars and gradually compress them down and down and down until the galaxies are not light years apart. You know, they're almost rubbing elbows.
But what is the relationship between infinite?
Compressing. I'm coming to that.
Sorry.
Then as you compress them down still further, they're occupying a smaller and smaller volume until perhaps the whole matter of the universe is inside my closed hands. And the density there is phenomenal. You know, the whole business of the way in which atoms are constructed with electrons and neutrons and protons all start to break down because of the enormous space that there is in an atom. I mean, if you haven't heard this example, if you take a great cathedral like St. Paul's Cathedral in London, or the great cathedral of the Vatican, or whatever, and you imagine that you've got an orange and an apple side by side, right in the middle of that cathedral, the whole cathedral, an orange and an apple. You take a frozen pea and it orbits outside the cathedral. That is the ratio of mass to space in the hydrogen atom. You take a bottle of hydrogen gas and you try and see how much, if you can break down the structures of the atoms so that the subatomic particles were touching each other, you wouldn't even be able to see it in that bottle. You wouldn't be able to see it in the bottle, you wouldn't be able to detect it in the bottle. So when we're talking about the volume of the universe coming down towards infinity, we're saying that there's a point where suddenly there's no space at all. And at that point, the density is infinite. You got it?
Yeah.
Yes, Eddie?
Colin, I would much rather be at your shivering bus stop than go to a disco party.
Supposing it was a Beethoven concert.
It's not a party then. But seriously, you know about the Cambridge conference organised by the Scientific and Medical, where they're talking about multi-universes, which so closely resonates with, well, what we would say universes in coadunition but not in consubstantiality.
Yeah.
In other words,
Yeah.
different material but strung together as one.
Yeah, well, this was the whole business of this, you see.
Yeah.
The separate three-dimensional universes existing in a much bigger dimensional volume.
Strung together.
Strung together, perhaps, yes. Yeah. Yeah.
But the point I'm making is that conference is another example of the coming together of the esoteric and the conventional sciences,
Yes.
who are talking to each other in a big way.
Yeah, but you see, you might have felt that this talk was rather academic in some respects, but you see, it's intended to show you that there has to be a way of going through a gateway into another realm of thinking. That is really the purpose of this talk, to a large degree, to really amplify what Jocelyn was saying this morning, you know, that there's another way of thinking demanded of the person who wants to get to grips with the esoteric philosophy. Another way of thinking. And until you are prepared to come to grips with it, it will still be on the outside of you as a possibility that yes, you might be interested in it. It's a fascinating idea, but it hasn't become a reality to you. There's a point at which it becomes a reality. And at the point at which it becomes a reality to you is a point where you know that you know. And that is an incredible point for anybody to reach. Because the moment you know that you know the truth, that there is another realm, that life doesn't come to an end when you die, that there's another way of experiencing your own personality, your own consciousness, that is absolutely incredible. That is an incredible moment for anybody. Anybody else? Yeah, yes?
Colin, could you describe this density as a black hole, what the scientists call a black hole? When it all comes together.
Yes. He says in the article, you might like to read the article because you're picking up on the vibrations from the article. He says that as it comes down towards this infinite density, it could be turning into a black hole. And that this black hole is not a point in space, it's a moment in time. And when we're talking about a moment in time, we're talking about time of the order of 10 to the power minus 32 seconds. 10 to the power minus 32. Now, those of you who are not mathematicians, that is, oh dear. It's such a tiny fraction of a second that it's almost impossible to imagine it. 10 to the power minus 32 is in fact 1 upon 10 to the power 32, which is in fact 1 upon 10 times, with 32 noughts after it. With 32 noughts. 1 upon a billion, which is such a tiny, tiny fraction of time that it is almost, it is totally unimaginable. And yet that is what we're talking about. At this instant moment when the Big Bang is alleged to have occurred. But which isn't necessarily the Big Bang at all, it's just the reversal of an implosion into an explosion, which is what he said in the conclusion to his article. Yes, anybody else? Well, we've had our time, it's 12:30, so I suggest we're not, I should have said this at the start of the previous session, we're not into clapping, we're just into Namaste.